Welcome back. Last time we discussed the superior planets and their orbits. So this time we're going to discuss the inferior planets and the orbits of those. Last time we started with a diagram where I drew several different, like a movie basically. And in that diagram, we said that if the planets start in the same place, the farther out planet moves less. So this is still true. For our superior planets, that meant that when we drew the full diagram, we drew the numbering system going clockwise, even though Earth moves counterclockwise. But this time, Earth is on the outside. So because Earth is on the outside this time, we're going to draw the numbering system going counterclockwise like Earth moves. And this is because the inferior planets do appear to move counterclockwise. They do move faster than Earth does. All right, so we're going to start with the exact same thing. We're going to have our concentric circles with the sun in the middle and with the planet on the inner ring, and then Earth is going to be on the outer ring this time. So let's go ahead and draw that. We've got Earth hanging out over here. We've got the sun in the middle. And this time we'll follow Venus. So Venus is going to appear in some slightly different locations. There's going to be one here. There's going to be one in a weird location. So it needs to be a location where, and I'm going to use like a guideline here, a location where from Earth, it's perpendicular to the circle. So it's going to appear here. For completeness sake, I'm going to put one in between them for a reason you'll see in a second. We're going to place one way out here. We're going to place one over here. That was a bad circle. Let's draw that again. One over here. And we're going to place one in the exact same type of location from Earth perpendicular, except on the other side this time. So that's like roughly there. Excellent. Let's go ahead and number these. So we're going to number them going counterclockwise this time, because from Earth, this planet actually will appear to be moving counterclockwise. So we're going to call that 1. We're going to call this one 2, 3, 4, 5, and 6. So there are 6 different locations here. Let's go ahead and list our circles. So circle 1, 2, 3, 4, 5, 6. All right. Again, we want to take a look at Earth as it rotates. So the sunlight is going to cause a shadow to appear on the back of the planet here. And the front of this planet will be illuminated. So it's daylight on one side and nighttime on the other. Notice something about this. So right away, this is different, right? The planet always appears on the day side of Earth, meaning that the only real time you can see an inferior planet is during sunrise, during sunset, or during an eclipse. So during a total solar eclipse, it actually does get dark enough that you can see these planets. And again, we want to make this a little bit easy for ourselves to identify. So going from daytime to nighttime is morning or sunrise. And let's go ahead and move this down a little bit. Perfect. And then going from nighttime to, oh, I messed that up, didn't I? Yeah, that's not right. This is backwards. So going from day into night is evening. And going from night into day is morning. Oops. Let's try that again. So evening, morning. Perfect. So going from day into night, that's our evening. Going from night into day, that is sunrise, that is morning. Okay. So let's go ahead and take a look at this the same way we did last time. We've got sunlight coming in. Oh, oops. We've got sunlight coming in. And that sunlight is illuminating our planet. So I'm going to go ahead and use like, oh my goodness, I'm really messing this up today. It's going to illuminate our planet like that. And that means the shadow is going to be cast on the other side like that. And let's take a look at how this looks from Earth. So from Earth, we can only see the dark part of this planet. Right, so at 1, this entire face, so we'll call this 1, 2, 3, 4, 5, 6. This entire face is going to be dark. So this phase is new. And we learned last time that this is called a conjunction. And so the type of conjunction that this is, and it's conjunction because the planet will appear to be in the same region of sky that the sun is on, right? So it's on the exact same side. The type of conjunction this is called is an inferior conjunction. And it's an inferior conjunction because the planet is between Earth and the sun. So just like the inferior planets are between Earth and the sun, and the superior planets are outside of the Earth and sun, the inferior conjunction is between the Earth and sun. All right, so let's go ahead and clean this up a little bit. Next up, number 2. So number 2 has the sun illuminating part of the planet. And then Earth sees that part of the planet like this. And you'll notice that the arrow I've drawn from Earth and the arrow I've drawn from the sun form a right angle. That's not by accident. So remember, when I drew number 2, I said that we wanted to draw this so that the Earth's viewpoint of it was perpendicular to the orbit. So at number 2, we actually have something that looks like this, where the Earth will see exactly half of this planet being illuminated. And from the viewpoint that I've drawn right now is, it's going to be the left half that's illuminated. So the right half is in shadow and the left half is being lit up. So the phase here is half. We don't call it quarter because it doesn't take place a fourth of the way through the cycle. It's just called half. And I'm actually going to write the location, or the name of the location down here. So this is what is known as greatest western elongation, or sometimes greatest morning elongation. So greatest western elongation, what does that mean? Well, as seen from Earth, this is the farthest that the planet will ever get from the sun. So that's what greatest elongation means. And then this is visible in the morning. So since it's visible in the morning, that means that the sun is going to be on the eastern horizon. So it's going to be somewhere in the east. And this planet is going to appear west of the sun. So greatest western elongation. So greatest elongation, farthest from the sun, western because it is on the west side of the sun. All right. 3, of course, is going to be illuminated directly. So 3 is going to be illuminated directly by the sun. And from Earth, 3 is going to be directly seen face on. So it's going to look something like this. Where half of it that's being illuminated is directly being faced by Earth. So this is going to appear full. And I should probably fill that in. So let's go ahead and fill this in. Now, the type of conjunction here is a little bit different. So it is full. And you know what? Let's just do that. This is a superior conjunction. So it is a conjunction, and it is a conjunction because it appears to be in the same part of the sky that the sun is at. It gets very close to the sun. They're on exactly the same side of the Earth. And it's superior because it's outside of the Earth and the sun. So let me show you what I mean by that. So the Earth and the sun are over here. Right? Here are the Earth and the sun. And number 3 is outside of the Earth and the sun, and number 1 is inside the Earth and sun. So number 1 gets the name inferior because it's between the Earth and the sun, and number 3 gets the name superior because it is outside of the Earth and the sun. 4 doesn't have a special name. So I'm going to go ahead and lay that on you right now. There is no special name for the location of 4. But I did want to include 4 so that you can see what its phase looks like. 4 is one of the harder ones to draw. So let's see if I can get it right the first time. So 4 is going to be shaded so that this half, let me actually pick the correct tool first. This half is the bit that faces the sun, and this other half is the bit that faces away from the sun. But Earth is facing 4 like this, right? So Earth is going to see the right-hand side is illuminated and the left-hand side has a slight shadow on it. So 4 is actually a gibbous phase. There is a gibbous phase also between 2 and 3, but I didn't draw it in because I don't feel the need to. If you were to see a blank slot left between 2 and 3, that would be a gibbous, but it would be illuminated from the right-hand side instead of the left-hand side. So 4 is just a gibbous. It doesn't have a special name. There's nothing exciting happening there. 5 is the exact same idea as 2. So it is a greatest elongation. But with 5, we've got something a little bit different going on. Because with 5, it's not just that it's an elongation, it's an elongation on the other side, right? So instead of being a half that's illuminated from the left, it's going to be a half that's illuminated from the right. Like this. Oh, oops, that's not what I meant to do. Like this. So it's going to be illuminated from the right. And it's also going to be visible in the evening. Currently, Venus is visible in the morning. And I believe Mercury is also visible in the morning. Mercury is actually approaching greatest elongation. I don't remember what day greatest elongation for Mercury is. I want to say it's like the 17th or something like that. So if you looked out in the morning and you were to look for Mercury, it actually is very hard to spot, even if you know where to look. But now would be a good time to try that. So this is greatest. And it's in the morning, so the sun is on the west. Sorry, it's in the evening. So the sun is on the west. Yeah, so the current planets are visible. Mercury and Venus are visible in the morning. The sun, in this case, this is an evening elongation. So the sun is going to be in the west, which makes this an eastern elongation because the planet is going to be east of the sun. And this is visible in the evening. Oh, and silly me, I forgot completely to fill this in. So it's going to look like this. All right, last but not least, we have number 6. Number 6 actually does have something going on for it. There is a name for this location, but it's a bad name, so I'm not going to teach it to you. It's not a very good description of what's actually going on. So number 6, you don't need to know what the name of this one is, but let's go ahead and draw it in. So the sunlight is shining on exactly half. And from Earth, the bit that you can see is going to be perpendicular to that line that I just drew. So like that, mostly shadow with a tiny sliver. And the shadow part is going to be on the left. And the little sliver of right is going to be on the right. Of light is going to be on the right. So it's going to look like this. So it is a crescent. It is really important that we take a look at this, because if we were taking a look at the diagram where Earth is in the middle and we have the sun in the 3rd position and we have Venus and Mercury between the two, this crescent shape and the new shape would be the only things we'd be able to see. We would never see a half or a gibbous or anything like that. So actually this diagram is super important. This diagram eventually was the way we actually showed that the Copernican model was better than the Ptolemaic model. So a couple of takeaways here. For the inferior planets, every phase is possible. So unlike the superior planets where you only got full and gibbous phases, for the inferior planets, you should be able to see every single one. New, half, full, gibbous, and crescent, just like with the moon. One of the other takeaways here is that because of the position of Earth, these planets are only visible during the morning and evening, or during an eclipse. Yeah, I cannot type today. And the reason for this is the planets are close to the sun. So since they're closer to the sun, they only appear near the sun on the plane of the sky. And unlike our superior planets, there are actually 2 conjunctions and no oppositions. All right, so that's it for the configurations of the inferior planets. You should be able to draw both of these diagrams. So if I asked you to draw the superior planet configuration diagram, you should be able to do it. If I asked you to draw the inferior planet configuration diagram, you should be able to do it. If I gave you a blank version of this diagram and asked you to figure out what the phase of number 4 looks like, you should be able to figure that out. If I gave you the other one and I asked you what the phase looks like, you should be able to figure that out. So that's something to work on for exam 1. I'm not sure which diagram will show up, but diagrams show up on exam 1. So all of the diagrams we've done so far, the moon phase diagram, the shadow anatomy diagram that we did for the eclipse, both the inferior and superior planet configuration diagrams, those should be things that you were studying for the first exam. All right, so now that we have our planet configuration diagrams all figured out, we're going to go ahead and go back to the PowerPoint. I'll give you some of this information again in PowerPoint form, and then we'll move on to talking about Tycho Brahe. All right, I'll see you there.